Hi, my name is Newvick Lee. I'm a software developer. And today I'm going to give a talk on how to use Postgres views to revitalize your complicated or outdated data models. I think this is very relevant for software developers who are working in startup environments where your data model is constantly changing. I hope this is a technique that you can use to help you out. Now, first, I'm going to start off with a question. You're using a complicated and or outdated data model. It's a very common situation. What do you do? A, you refactor the data and all the related code. Now, this is the ideal solution here, but most of the time, we actually don't have the time or the resources to do all this refactoring as much as we love to. So we'll have to cross that out. Unfortunately, B, it is the only alternative to just give up and continue using this complicated data models grudgingly. I'm going to argue that you can actually do something else. And that something else is the topic of our talk and the goal of today, which is to learn about Postgres views and actually how to use them to improve your data models. This is an outline of what we're going to talk about today. We're going to first review an example case and then move on to what is a Postgres view and how does it actually help you. And then we're going to try creating a view and learn that actually views are updatable. But if we want to improve our update process, we can use triggers and functions. And there's also some useful parameters that we can look at. And finally, we'll end off with a short contrast between standard views and materialized views. Now, our case study is a complicated data model, and it's going to have some polymorphic associations. Here's our table, farm, animal, barn. We're going to just focus on 4 columns. And these 4 columns are actually grouped into 2 polymorphic associations. We can see here that the first one is the animal type and the animal ID. So that's one polymorphic association. And the second one has to do with the barn type and the barn ID. And we'll see what this actually means. Here is some example data. Now, let's just take a look at this first row here. If our animal type is chicken and animal ID is 5, this animal ID actually refers to the chicken table ID column. And if the barn type is large barn, the barn ID actually refers to the ID column of the large barn table. And then the second and third row shows you a bit more about what this polymorphic association means. So in these second and third rows, our animal type is duck. But if we look at barn ID, they're both 8. How is that possible? Well, that's because in the second row, it's part of the small barn type. And in the third row, it's part of the large barn type. And because they're referring to 2 different tables, because they're 2 different barn types, that means that it's okay for them to have the same barn ID because they're in 2 different tables. Just to make this extra clear, just because I want you to understand this case example before we move on, this is how it looks like if we kind of graph out the relations. So first, let's take a look at the one on the left here. So you see how animal ID is pointing to either the chicken or the duck table. So it can be either one depending on the animal type. And that's actually the same for the right side here. So the barn ID can refer to either large barn or the small barn ID column, depending on the barn type. So that's what it means to be polymorphic. And in our example, we have these 2 polymorphic associations. Now, how would you query for this using SQL? You would select from the farm animal barn table. And then in the where clause, you have to make sure you have at least these two clauses down. You have the animal type, which is chicken, and then the barn type, which is large barn. So that's how you query for a chicken in a large barn. Now, how we do that for if you wanted to query for a duck in a small barn. Select from that table again, and then the only things that change are in the where you would go for animal type equals to duck and barn type to be small barn. Very similar, except you just have to change the where clauses for the animal type and barn type. So this is our case example. It's used to represent probably potentially more complicated data models that could actually exist in practice. And for example, like these are some of the ways that it can be more difficult to work with. You could have potentially more animals, more animal types, maybe a cow or horse. You can have many more barn types as well. A wooden barn, maybe a small one, extra large. And you can also have a lot more polymorphic associations in the same table. So I've seen all of these cases in practice, and that's why I chose to use this example case as something that could be very complicated. Now that we've learned what our example case is, we're going to move on into what is a Postgres view. So just briefly, a Postgres view is a virtual table. It does not store any data, so it's not physically materialized. And what it is, it's just a predefined SQL query that acts like a regular table. You can think of it as a shortcut for that predefined SQL query. And this is the syntax that's pulled from the Postgres documentation. You can see that in the first image there, you do a create, and then there's a bunch of options, view as, and then there's a bunch of options as well. I will slowly get into that. You don't have to worry about that yet. So let's take a look at the second image there. Create view vista as select, and then it's just hello world string as the hello column. So if you want to see just a very simple example of what it looks like to create a view, this is it. You have one column with one row, and that's the simplest case of a view. Now that we kind of understood what a view is, let's try using a view to help with our example case that we looked at earlier. Now, if you remember, this is what it looks like if you wanted to query for a chicken in a large barn. It's actually, it can get relatively complicated. You have at least 4 different where clauses here. And then you have animal type, animal ID. It can get a bit confusing. So we're going to improve this. And the first step we're going to do is to create a view for this. So let's take a look at the syntax here. We're going to create this view, and then the name of our view as. And everything after the as is our predefined SQL query. So we're going to select, and then actually going to talk first about the where clause. We're going to select from the farm animal barn table. And then in the where clause, we have 2 specific ones. The animal type equals to chicken, and the barn type equals to large barn. And because in our view, we'll always have chicken and large barn, that means that the animal ID, we can rename it as chicken ID to make it more clear. And same for the barn ID. We can rename it to large barn ID to make it clear that that is a table where the ID comes from. And after we've created that view, we can use it to query. So I have this contrast here to show you what that difference is. On the left side here, we have the original query. It's quite long and it can be a bit complicated. On the right side here, when we're using a view, we can see that it's actually a lot simpler, less lines of code, and also more clear. So we're doing a select, these 3 columns, from chicken and large barn. That's the name of the view. And we can see that it's not animal ID, it's actually chicken ID, because our view says that this view will only show chickens, and it shows a large barn ID because this view will only show the large barn. You can see that it's a lot simpler to work with, and it's also more intuitive as well because the columns are named after the types in the view. Now, after we've queried for it, what does it actually look like? Let's take a look here. On the left side, that's what the original table looks like, the farm animal barn. And then on the right side, we can see that it's a lot more succinct. So let's take a look at the animal polymorphic association first. So you can see the animal type chicken and the animal ID 5. It kind of gets transformed into just chicken ID 5. And also the same for the barn polymorphic association. These two columns, barn type, barn ID, they get transformed into large barn ID. And you can see the view is a lot simpler. The outcome of this is that now querying is much simpler for these polymorphic associations. So we saw that you can query for chicken and large barn, but you can also create views for the other types. For example, you can create one that's specifically for maybe a duck in small barn or a duck in large barn. And all these views will make querying a lot simpler for the types of data that you want. Now, you might be wondering, what about other actions? We don't only query data, of course. We also do insert, update, and delete. How do these views treat these other actions? That's a really good question, and I think you'll be happy to hear that views are updatable as well. In fact, they are automatically updatable. They satisfy those conditions. Now, what does it mean for something to be automatically updatable? So in our example view, we had chicken in large barn. We could just do a select star from that table and we can get the data we want. Now, if it's automatically updatable, it means that we can just do insert into that table, into that view, chicken large barn. We can do an update, we can do delete. That's what it means to be automatically updatable without doing any extra work. But it has to fulfill all these conditions. So it has to have exactly one entry in its from list. Also, it should not contain anything like with, distinct, group by, having, limit, or offset clauses. Also, it must not contain any set operators. So stuff like intersect and union. And the select list, finally, it should not contain any window functions, aggregate functions, or any set returning functions. So if your view fulfills all these conditions, you can update it without doing any extra work. And like I just mentioned, this insert into our view with chicken ID 2, large barn ID 3, that's actually possible without doing any extra work. But, and there is a but the animal type and the barn type will be null. So that is a bit of a problem because they definitely can't be null. If they are null, then how do we know what they actually refer to? So that's where trigger functions come in. If we want to improve the update onto our views, we can use a trigger to replace the insert on the view. Let's take a look at what this is doing. So first line and second line, we're doing a create replace function, and then we're naming our function. And then in the third line, we can see that we're returning a trigger. And if you haven't used triggers before, I'll show you later on why we're actually returning a trigger. But the meat of this function is actually in between the begin and the return. So in that insert statement there, we're going to insert into the base table, the physical table, farm animal barn. And let's take a look at the first column we're inserting into, animal type. We are hard coding that as a chicken string. And why are we doing that? Because remember, we're inserting into our view chicken and large barn. So it expects that everything we're inserting into is of the chicken animal type. And then what are we going to insert into animal ID? Well, we're just going to pass through that chicken ID into animal ID. No extra transformations needed. What about for barn type? Remember, this is the large barn view here. So we're going to hardcode that string to large barn. And finally, what about the barn ID? Same as the chicken ID here. We're just going to pass through the large barn ID into a farm animal barn ID. Now before we saw that this function was actually returning a trigger. And why is that? Because this function actually has to replace the insert on the view. Let's take a look at the first line there. Create trigger, and then we have the name of the trigger. And the second line is the meat of it. So instead of inserting in the view, what we're doing is we're going to place that insert, and we're going to run our trigger function for each row that we're inserting into the view. Now, if you want a bit more intuition about what this trigger function is actually doing, I hope that this diagram clarifies it a little bit. Let's start at the very top here. We have the insert into our view. Now, normally without a trigger function, it will go directly to the physical table. But what's happening here is that we're replacing that insert with our trigger function. So for every row that you're inserting into the view, we're going to run that through a trigger function. And then our trigger function actually inserts, after some transformation, it inserts into the underlying physical table, which is the farm animal barn. So this is kind of the intuition about what this trigger function is doing. We can see that the insert now fills our animal type and barn type columns. So in the left side here, we have insert into chicken large barn. And let's take a look at chicken ID 2. It gets passed through, and then chicken ID goes into the animal ID column, and then animal type is automatically hard-coded as chicken. And same with the large barn ID. It gets passed through into barn ID 3 there. And then we can see that the barn type, it was hard-coded to a large barn because that's the name of that's the type of the view that we were inserting into. And that's what the trigger function is doing when it transforms our data and then inserts it into the farm animal barn. Now, we only looked at this method for insert, but if you need to do it, you can also use the same method for update and delete, and it will work. So it's very handy. But as you call, if your view is automatically updatable, you do not have to do this. You can just do an insert, update, delete into that view without doing any extra work. You only have to use trigger functions if you want to do some augmentation. And that's why we use the trigger function here, because we actually wanted to do that augmentation. We wanted to fill out those type columns with the specific type of the view. And we saw how, with all these examples, we saw how views can actually easily improve your data model without affecting the underlying tables. Now that we've kind of understood how to use views, I'm going to move on to some useful view parameters. In the beginning, we saw that there's actually a ton of options that you can use when you're creating your view. You can see there some of the options there. We're going to focus on two types that would be pretty useful for most people. The first one here with cascaded local check option. This one controls the behavior of automatically updatable views. So if you specify this option, then any insert and update commands on the view, they are first checked to ensure that these new rows that you insert or update, they can be seen through the view. What does this actually mean? So let's take a look. Remember our previous example of chicken and large barn. Let's say we want to insert like a duck in a large barn. If we specify this option, we cannot insert a duck in large barn into our chicken large barn view because it will not be viewable through the view. So this is actually a very handy way of making sure that your view maintains data integrity. And that's very useful for because if you're trying to improve the data model, you want some sort of data integrity like this. The second option here is to do with security. So the first type of Boolean we see here is the security barrier Boolean. What this does is it allows the view to provide role level security, and it's very handy if you do need to use that. The second one is also pretty interesting. Security invoker, it's also a Boolean. It checks the base relations against the privileges of the user rather than the view owner. Now, what does this actually mean? So let's say your base table, in our case, the farm animal barn. We have some security checks there that checks against the user. If you invoke this option, then that means these security checks from the base table are also used by the view without any extra work. So it's very handy if you want to make sure that your view has the same security access or same security privilege checks as your underlying relations. And finally, we're going to take a look at views and materialized views. Now, the main difference is that your standard views, they are virtual. They don't store any data. But materialized views are the complete opposite. They are physical, meaning that they store data in your database. They actually have these physical tables. So that means they will have different use cases. So our standard views, the common use cases are maybe simplifying data models like what we've just seen here, and also encapsulating complex queries. But because materialized views are physical, they have very different use cases, usually to improve the performance of read-heavy workloads, or maybe for aggregating and summarizing data for analytics. So if you come across materialized views, I think hope that you now understand the difference between the standard views and materialized views. And after hearing all this, I hope we've accomplished our goal for today, which is to learn about Postgres views and how to use them to improve your data models. We've learned that views are virtual, and then we went through an example case where we created our view. And we can also see that they're automatically updatable. But if you need to, you can use trigger functions to augment the updates. After that, we move on to some useful view parameters that you might want to look into. And we talk very briefly about views versus materialized views. I hope that next time you come across a complicated or outdated data model, and if you don't have any time or resource to refactor the code, instead of giving up and using it grudgingly, I hope you'll look into Postgres views and see that they can help you improve your data model. Thank you.